Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Well, everyone, now here I want to review again the material about momentum in physics 11th grade. Okay, and I will give you an extra material that was the most common case in momentum. That was about collision. Okay, have you ever played billiard, or maybe have you ever watched a car crash, two car crashes each other, like in this picture? Okay, if have, so that those are the examples of the momentum and impulse in the real life. Yeah, and we can analyze that phenomenon in physics. But first of all, we have to know some quantity that we will talk about in analyzing this case. Okay, the first quantity is momentum itself, and momentum is defined as the quantity of motion of a moving object. Okay, the higher the mass will be higher the momentum. The higher the velocity will be higher the momentum as well. Okay, so P, it stands for momentum in kilogram meter per second. M is stand for mass in kilogram, and V is stand for velocity in meter per second. Okay, then second is impulse, and impulse means the change in momentum. Yeah, in mathematical one. So I, because the change in momentum, so we can equals this I with delta P. As we know that delta, it means that there is a change in the quantity of momentum. So uh, the change itself will represent the different condition between the final and initial state. So this is the final momentum and this is the initial momentum. When we subtract those quantity, the final of momentum and initial momentum, it will be impulse. Okay, then third, we will also talk so much about the law of momentum conservation. Yeah, we will look at the initial state and the final state. When the this is actually the P1 and this is actually the P2. When there are two mass or two different momentum, yeah, and let's say that they are colliding each other, so we have to look at the after or the final state after the collision itself. So we will have P1 accent and P2 accent, yeah, to represent the final state of the momentum quantity itself. Okay, so when P1, P2, yeah, it added, it's equal to P1 accent plus P2 accent, so it allows the law of momentum conservation. Okay, conservation, remember, conservation is stand for the process that conserve or fix. Yeah, there's no change on the quantity of in this law, so the momentum will be fixed. The fourth one is the law of kinetic energy conservation. Okay, in the law of kinetic energy conservation, we will see that the kinetic energy, yeah, of the initial state will be the same as the final state. And as we know, the kinetic energy itself has a formula half times mass times velocity squared, like this. Okay, now I will introduce you as well the types of collision, and we will compare between all of the types here. Okay, the first one is elastic collision. Okay, for the elastic collision, the momentum will conserve. And I guess for all of the types in the collision, the momentum will always be conserved. Okay. Oh yeah, talking about collision itself, collision it means um, when there are two different objects colliding or hitting each other. Something like the previous case, yeah, when we have this white ball billiard, when we hit by using a staff, then the white billiard will hit the other ball, right? And that was actually the process or the phenomenon of collision, yeah, or colliding. Okay, so in every types of collision, the momentum will always be conserved. Okay, you can see here. But for the kinetic energy, the value or the magnitude of kinetic energy will be different. For elastic collision, it will conserve. But for inelastic collision, it will not conserve. And it can be changed the form of energy into heat, sound, etc. Okay, then the third one is perfectly inelastic collision. But for the momentum still conserved, but and in the kinetic energy, they will felt the maximum loss of kinetic energy. Okay, but please note that the maximum loss of kinetic energy it's not mean that there's no kinetic energy at all. Okay, it can be, but uh, it will not always having no kinetic energy at all. Okay, and for the common case in this type of collision, for elastic and inelastic, the object will not sticking each other after the collision itself. Okay, so it's not sticking each other, but for the perfectly inelastic, they will stick each other. Okay, just like the car crashes, yeah, two car crashes, yeah, when the two car crashes they will stick each other, yeah, stick together, then move together, yeah, with the same velocity of those cars. Okay, and now, yeah, let's have a look on the last column. We have the coefficient of restitution. Okay, and actually I will explain to you about the coefficient restitution after this slide. But first of all, I want to introduce you about the comparison between elastic, inelastic, and perfectly inelastic collision value of the restitution. Okay, in elastic, the coefficient of restitution will be equal to 1. Yeah, perfectly bouncy. And for the inelastic, it will range from 0 until 1, but not actually 1 and 0. Yeah, so this is partially bouncy. And the last one, when the two objects is sticking each other and the kinetic energy is felt the maximum loss, yeah, so the perfectly inelastic collision will have uh, E equals 0 for the coefficient of restitution, so it means no bounce at all. Okay, one more material. Okay, this is coefficient restitution. Okay, the coefficient of restitution, often written as E, yeah, like this, is a measure of how bouncy a collision is. Okay, it's defined as the ratio of relative speed of separation after collision to relative speed of approach before the collision. Okay, actually we can cover that definition by using this kind of formula, and we can see here this is actually the relative velocity, yeah, or speed before the collision. And for the below one, yeah, this is actually the relative velocity as well, but for the after collision one. Okay, yeah, I guess it will be easy for you to remember this formula that E is equal to minus V2 minus V1 divided by V2 accent minus V1 accent. Okay, like this. And this is actually the sample case of the bouncy measurements or number or value. Yeah, when we collide two billiard balls, here we have 13 billiard balls and 8 billiard balls, and let's say that they uh, collide each other, then they will have, yeah, will move in different or in opposite direction. Let's say that this is V1 and this is V2. Okay, then the ball will collide each other in one point. Let's say that in here. Then after that, the ball will not stick together, but it will repelling each other. Yeah. So the V1 will be directed in opposite direction as before. So this is V1 accent, and for the V2, it will be V2 accent like this. So accent mean that this represents the process after the collision itself. Okay, and for additional information about the coefficient restitution itself, in physical meaning, it tells us about how much kinetic energy is retained in the motion after collision. A higher value means more bounce, while a lower value means more energy lost to deformation, heat, or sound. Yeah, deformation, heat, or sound itself, it one form of the change of energy. Yeah, where do we can find the energy resulted after one process itself. Yeah, we can find it by using the previous condition or previous activity, or the the other effect that maybe we can uh, get from that process. Yeah, sometimes like deformation, heat, sound, light, or something like that. I guess that's all.